Review sheet C question 4. We're now going to do some completing the square. Let's take that first one there. So I've got y equals x minus 3 all squared. The 3 is because I've got half the 6. Minus 3 squared and add the 7. And so y equals x minus 3 all squared, take away 2. What does that one look like? Well, it looks like quadratic. The minimum point at 3 minus 2 down there. So it's like this. It's 3 minus 2. And that point there, that's going to be 7, isn't it? I can see it's going to be 7 from the value there. For part 5, it then says, what's the line of symmetry for that one? So the line of symmetry is all the way down the middle there, and that's when x is equal to 3. X is equal to 3 for that bit there. We could check that on the calculator if you wanted to. Let's put our quadratic equation in here. So our quadratic equation has got x is 1, a is 1, the b value is minus 6, and the c value is 7. We don't care actually this time about what two solutions to that equal 0 else. We do want the minimum. The minimum was x is equal to 3, and when y is equal to minus 2. And that's what we said, 3 minus 2. So you can use the calculator to check these. So let's go on without the calculator. The progression here in part B is you're now looking at a fraction here. So we've got 3 over 2 in that bit there. And some people then struggle working out what 3 over 2 all squared is. It's 9 over 4. So I'm talking about quarters here, so I'm going to change this into quarters as well, and that's 20 quarters there. So my final answer is minus 29 over 4 there. And what's my quadratic going to look like? Well, it's going to have a minimum point this time at 3 over 2, and at minus 29 over 4, so somewhere all the way down there. I also know it's crossing here at minus 5, that's from that bit there, and so I'm looking at a quadratic that looks like that, with a line of symmetry down there when x is equal to 3 over 2. Scrolling down and continuing for part C then, so what is the question? So let's write it down. Y equals 2x squared plus 4x plus 9. And the other one I've got to do down here is with the negative. So this progression, it keeps getting more difficult as we go down here. Let's do this one this way. We'll take out the factor of 2 here. And that gives me x squared plus 2x here. And there's also a plus 9 over there. This x plus 2 here can be x plus 1 all squared, take away another 1. Notice I've got 2 sets of brackets there. That's where people would go wrong with that one. And multiplying that out, that gives me 2 lots of x plus 1 all squared, take away 2 there. And the final line, 2 lots of x plus 1 all squared plus 7. So one way of doing it would be to use lots of brackets. I'll do this one the other way around. The other way around is actually take the minus over here. So if I take a minus over there, that gives me x squared plus 6x minus 1 there. And that gives me x plus 3 all squared, take away 9, take away another 1. And so that's x plus 3 all squared, take away 10. But of course that was what I've got for minus y. So now times by minus 1, minus 10 times minus 1 gives 10. And this times by minus 1 makes minus it. And so that is what we get there. We could always check this by, I don't know, so throwing in 1. Put a 1 in there, we'd get 4 here, 4 squared is 16, 10 take away 16 is minus 6. Put a 1 in here, we get 1, take away 6, take away another 1, does indeed give minus 6. So you can check whether they've actually worked or not. What does that one look like? Well, that one looks like it's got a maximum point this time, because it's an upside down one, a maximum point at minus 310, and so it's going to look like this. That point there we knew from earlier was going to be, what was it earlier? Was it 1 earlier, I think. And this one over here, I've not drawn the graph of that one there, have I? So this one here has got a minimum point at minus 1, 7. Minus 1, 7 is there, so it's looking like that, and it's crossing there. I can't see where it's crossing there from earlier. Where is it crossing there? It's crossing there at 9. There's what the pictures would look like.